So welcome to our session. So type 3, so f of d comma d dash and z is equal to trigonometric functions, either cos or sin is given. So here also the coefficient of x is our a and coefficient of y is our b. So problem number 1. So solve d square plus d dash minus 6 d dash square into z is equal to cos of 3x plus 2y. So the given partial differential equation is d square plus d dash minus 6 d dash square into z is equal to cos of 3x plus 2y. Since it is a homogeneous equation, we can replace d is equal to m and d dash is equal to 1 and also rh is 0. So we can get auxiliary equations. Auxiliary equation is m square plus m minus 6 equal to 0. Replace m is equal to minus 3 and 2 in your complementary functions. So we can get a complementary functions. So particular integral is 1 by f of d comma d dash into cos of 3x plus 2y. So replace a is equal to 3 since coefficient of x is 3 and b is equal to 2 since coefficient of y is 2. So therefore d square is equal to minus a square, a is equal to 3, so we can get minus 9. And also d dash is nothing but minus a into b, replace over a and b, so we can get minus 6. And d dash square is equal to minus b square, so replace b is equal to 2, we can get minus 4. So in this case only we can replace in the form of d square or d dash or d dash square. Suppose if it is simply d is there or d dash is there means we are unable to replace it. So either d square or d dash or d dash square. If it is in the case of three form, we can able to replace the values minus a square or minus ab or minus b square. Suppose d and d dash are alone, so we are unable to replace. Therefore, instead of d square, we can replace minus 9. Instead of d dash, we can replace minus 6. Instead of d dash square, we can replace minus 4. Therefore, we can get this. So, simplify this, we can get 1 by 9. Since denominator is non-zero, we can stop the process. The process is over. Therefore, particular integral is 1 divided by 9 into cos of 3x plus 2y. So hence the general solution is that is equal to complementary function plus particular integral. So replace your particular integral and complementary functions value, we can get z. Example number 2, solve d cube minus 4d square d dash plus 4d dash square and z is equal to 6 times of sine 3x plus 6y. Therefore, taken as a given partial differential equation taken as equation 1, since it is homogeneous linear partial differential equations, so we can replace d is equal to m and d dash is equal to 1. So the auxiliary equation is m square minus 4m square, sorry, m cube minus 4m square plus 4 equal to 0. Therefore, solve this one, we can get 0, 2, 2. So first root is not repeated, second and third roots are repeated. So we can get complementary function is phi 1 of y plus phi 2 of y plus 2x plus x into phi 3 of y plus 2x. So now we go to find the particular integral. We can replace the f of d comma d dash. We can get this. Since in the denominator d is a commonly bring out the d outside, we can get this. So now we can replace instead of d square here, coefficient of x is our a, coefficient of y is our b. Therefore, a is 3, b is 6. So we can find the d square is minus 9, d dash is minus 18, d dash square is minus 36. So bring this 6 here, bring it to front, we can get 6 divided by d. So 1 divided by, we can replace the d square, d dash and d dash square, we can get this. So therefore denominator is minus 81. So now we can rewritten as 6 by minus 81, 1 by d into this. So 1 by d means, so 1 by d of f of x comma y means we can represent integral of f of x comma y into d dash. Suppose if it is 1 by d dash means we can return as integral f of x comma y into dy. Therefore d dash means integrating with respect to y, d means we can integrating with respect to x. So therefore particular integral is equal to minus 2 by 27. So integral of sine 3x plus 6y into dx. So integrating this, we can get minus cos of 3x plus 6y. Integrate again, differentiating the theta. So differentiation of 3x is 3. We can get, just we simplify this, we can get particular integral is equal to, so 2 divided by 81 into cos of 3x plus y. So replace your complementary function and particular integral. So we can get the general solution. Next problem. Solve 2d square minus 5d dash plus 2d dash square is that is equal to 5 times of sine of 2x plus y. So the given partial differential equation is 2d square minus 5d dash plus 2d dash square is that is equal to 5 times of sine 2x plus y. So this is the homogeneous linear partial differential equations. So d is equal to m, d dash is equal to 1. So now RHS is equal to 0. The auxiliary equation is 2m square minus 5m plus 2 equal to 0. So solve this one, we can get the roots are 0, 1 by 2, 1 to 2. So now the complementary function is phi 1 of y plus 1 by 2 into x plus phi 2 of y plus 2x. So particular integral is 2d, we can replace f of d comma d dash into 5 times of sine of 2x plus y. So here coefficient of x is a and coefficient of y is b. So therefore a is equal to 2 and b is equal to 1. Therefore d square is minus 4, d dash is minus 2 and d dash square is minus 1. So now we can replace the values of d square. So d dash and d dash square. So we can get the denominator is 0. Since the denominator is 0, as usual we can multiple x in the numerator and partially differentiating with respect to d. So differentiating with respect to d means we can get, so 4d minus 5d dash. So already we discussed, we can replace in the form of only d square or d dash or d dash square. But here it is in the case of only d and d dash. So we want to replace in the form of d square or d dash or d dash square. Therefore, we can take the conjugate. So multiple and divided by 4d minus 5d dash. So this is of the form of a minus b into a plus b. So we can write a square minus b square. So 4d square is 16d square. So minus 5d dash square is 25d square. So again you have to multiple 4d with the sine of 2xy and 5d dash with the sine of 2xy. We can two terms. So already we discussed d is nothing but, so dou divided by dou x. So d dash means is dou divided by dou y. Therefore we can differentiating the term. So with respect dou y, the dou by dou x, we can get cos of 8 times of cos of 2x plus y plus 5 times of cos of 2x plus y. Therefore just we have to simplify this thing, we can get particular integral is minus 5x by 3 into cos of 2x plus y. Therefore replace our complementary function particular integral